structural repairs technical at Fosrock. I'm looking after all repair things, bridges, dams, ports, jetties, multi-storied building, right from a small repair to anything. So repair is a wonderful subject. I'll try to see how best we can correlate. Anyway, we must understand the basics, tension, compression, these things, some durability tests and all. And very quickly, you see, when we see our ancient structures 2000 years back, how beautifully it was constructed. There was no softwares, no engineering course and all, how beautifully it was built. You know, these are all compression only topology, and when the structures are like that, life will be infinite. And they had self-healing concrete. And as they went up, it was all lightweight concrete, you know, as they go up and all. See how beautifully this is engineering, right? How well they had done. There are so many examples which we can take, we can motivate, and we get inspired and all. So I'm not going into details. Please see, cement and concrete are manufactured at very high temperature. They are bound to react with environment. Even M70 grade concrete will react and they will deteriorate because of inherent nature of materials, cement and steel. They are manufactured at a temperature of greater than 1400-1500 degrees Celsius. So what they do is they start to react. वो बहुत गुस्से में रहते हैं. They have inbuilt kinetic energy. They start reacting. They are not noble material. And there comes our practice. There comes our engineering. How we do it. So right from bug holes to honeycombs, they're all very critical. Repairs may not start 20 years, 30 years. It may start next day only. We have seen so many structures. This can happen. These needs to be repaired. See, a case had come. After 15 days, this is what is happening, right? Cement admixture incompatibility and all. If we leave it, then it is not okay. So we need to understand we have some repair material like structural grade repair mortar. You see the rheology. Please do not take cement sand and do it. This is a different engineering, the third world of engineering, where there are specialized materials that are available for structural repairs, which I am showing. And you see how beautifully they are engineered and doctored to do the performance. You see the rheology, you see fibers inside. They are non-shrink. Their modulus of elasticity is similar to that of concrete. So they are similar to concrete and work very well for concrete, reinforced concrete and all. Absolutely no cover. This is one of the hotel buildings where 15 days back we visited in Mumbai. No? This building was purchased for whopping 500 crore rupees, you know, in Mumbai. No? That is how Mumbai is. And you see the structure. There is absolutely no cover. And you see what is the stage of concrete and all. So you can see the condition. Cover. See, this is one of the slabs we visited. There is absolutely no cover, right? So today's philosophy is we are seeing how good is RCC, no? How great is RCC. See? Please remember one fundamental thing. When your center of gravity of footing and center of gravity of column coincide, then only there will not be additional tension. This is what happens here. So we have a lot of dampness and other things. So we have corrosion things. Too much steel. Please remember, too much steel is very bad. Please put as less steel as possible. In Delhi, many structures are like that. Township, like that. There are 30 towers, 35 storied, not more than 8 years, and you see the condition of the structure. Everything has come for repair. Now, I was looking at that column and I was telling, column, you don't have anything. Nothing is there left for you. And still you are taking 35 storied load. It means what? God lives in RCC. Today it is not class, sir. We are doing Kirtan of RCC. God lives in RCC. You know? Structure should have come down. Our theory fails here. Right? And that is how great is RCC. It is in Delhi. So column size, I guess, there were different sizes of the columns. The primary column was a square column which has bigger size. These are some of the secondary columns. There were different sizes of that. All the columns, even primary column 60 mm cover came out. 60 mm cover have come out. And I was watching like this and I am saying, God, you are in RCC, you are taking 40 floor loads. Otherwise RCC would not have taken, sir. So this is greatness of RCC, that we do so many mistakes, and this makes me to believe that that God exists. There is some superpower who is saving all of us, right? There are many stories. There are some stories where there was no foundation for building. The building touched together and they're taking the load. This is how wonderful stories are in structures. And anyway, we cannot depend so much also. This is bridge which came for repair after 2 years, right? In Gujarat, just 2 years and this is happening. This is the problem with our structures, needs repair, needs retrofitting. You see, we have micro concretes that are available, various grades of micro concrete that are available up to M80. So you can see the beauty of the products or the engineering behind the products, how the products are manufactured, how the products are engineered, how the product behaves for the structural things. They are polymerized, they are polymer modified. Lot of damages we can see. Earthquakes kill very badly. You see, these are one of the examples. These bridges, Kobe earthquake, Japan taught us. See, the bridges failed, but still we are very in bridges. You see, in India, we are fancy. I hate two things. One is cantilevering. That is called bad habit. One is cantilever, other is floating columns. There are two bad habits, right? We are very much focused, or we are very much obsessed with cantilever structures, right? Cantilevering and all. Believe me, cantilevers are, what I say, even new structures need to look in, and we need repair, rehabilitation, retrofitting even for new structure. Do not jump into repairs. Otherwise, repair tells that if you jump and blindly do the repair will come back after 2 years. Whether it is bridge, whether it is jetty, whether it is dam, whether it is port, we have experienced it. Numerous cases are there. I don't know the magic number, 2 years, it comes back. And again, you will have to do repair if you do not analyze properly. So we need to analyze properly. Anyway, NDT I am not covering because we have a specialist for NDT, I am not covering it. So I am taking 2 to 3 case studies. This is jetty repair. This is jetty repair where you can see the condition of the concrete. Nothing is left out, right? Still concrete is taking load. So what was done was additional reinforcement was put and shotcreting was done. Additional reinforcement was put, shotcreting was done. Shotcreting because the surface was more, and then the structure was retrofitted. There is a specialist coatings available. Now this coating, after setting of concrete, you apply it with brush. It will act as waterproofing, it will act as self-curing compound. You need not to do any curing. After 28 days, it will act as waterproofing. It will act as anti-chloride. It will act as anti-carbonation coating. Please, please, please coat your structures. It is like putting a raincoat to our, please coat concrete. So these are the things, these are the advanced technologies as civil engineer we must know, right? This is again something called as retrofitting, that is micro concrete jacketing. Very quickly, you add additional steel, you put, we put chemical anchors to put the reinforcement in place. You see, they are water insensitive, and then your structure is ready. And this is how jacketing is done. The second part I will go for fibers, you see, fibers. Now if you ask me why to put fibers, fibers are must. Fibers are must in structures. Why to put the fibers? I will say it will give me good sleep in the night. Tension is a problem. Tension is problem to us. Tension is problem to concrete. Don't take tension. Doctor says don't take tension. We say to building, don't take tension. Now tension, where tension comes, concrete is weak in tension. You can see concrete is very weak. Mass, heavy mass, and you have poor configuration of columns. The squarer the column, the circular the column, the better is the efficiency. I'm not saying any code is not talking about this. I am exceeding code and I'm saying that even this is a 40-storied building column, you know. I'm very worried about this because concrete creeps, concrete shrinks. There is a lot of tension in the concrete. So if we apply FRP wrapping, so it will take complete tension. This is like you coat it and you will apply the FRP wrapping, something like this, right? So the moment, last 3 to 4 slides, very quickly, concrete and God will thank civil engineer that we are helping them. Concrete likes confinement. Now coming to engineering, this was tested at Indian Institute of Technology, Mumbai. You can see cylinder concrete strength was 56 MPa. 56 is good, no? But one small wrap, you see the strength, 84 MPa. So actually see, we are not using even 30-40% of actual strength of concrete. Concrete is way beyond. So it's a very beautiful technology. It will be corrosion resistant and it will improve the tension of the concrete. So tension capacity. Concrete hates tension. I know we provide steel, but still this is a good thing to provide. So a lot of things are there to learn and all. We need to, the takeaway from today's thing is tension. Please ensure that concrete is not tensed too much. Second is cover. Third is curing. 1.5 is cut short to something.